Oh, yeah. Lightning. Don't you love watching electrical storms on a warm summer night? This is Dr. Nick for the ECG Academy, and we're going to be talking about electricity. And you're wondering, well, what does this have to do with this? Well, this is the electricity that your heart is generating. And in order to read an electrocardiogram, you have to know something about electricity. So that's what this lesson is all about. This lesson has to do with the basic electrical concepts that you really need to know in order to be able to read an electrocardiogram. And when we talk about basic electrical concepts, you really have to get all the way back to the atom. You have to know something about the atom, and that's what we're going to talk about. The atom, as you know, is the basic building block of matter. Everything is made of atoms. And the atom consists of a number of different parts. There's a central part that we call the nucleus. And the nucleus consists of a couple of subatomic particles. Those are the pieces that actually make up the atom. There are protons in the nucleus, and there are neutrons. Now, the difference is, and they're different colors here, the protons have a positive electrical charge, whereas the neutrons don't have any charge. Now, aside from the nucleus, there are these other particles that are flying around like moons around a planet, and these are known as electrons. The electrons are negatively charged, and they're flying around at different distances from the nucleus. Now, this is a picture of a carbon atom. Carbon is a very common compound, and it's in all of us. And in carbon, there happens to be 6 protons, and there are also 6 electrons. Most atoms in the normal state have an equal number of protons and electrons. And as a result, there's no electrical charge associated with a normal atom. Now, what is electricity? Well, most scientists think of electricity as the flow of electrons. And now, how can electrons flow if they're attached to this nucleus? Well, it turns out certain materials have electrons that are kind of loosely attached. And those electrons can be moved around, can be passed from one atom to another. These materials are known as metals. Well, we all know metals, right? Iron, copper, zinc, aluminum, those are all metals. Well, it turns out metals have a loosely connected electron. And if you have a bunch of atoms kind of all sort of like close to each other, then what happens is the electrons can jump from one atom to another. Okay? And so imagine a wire, a copper wire, and what happens is if you shove a bunch of electrons in one end of the copper wire, it pushes all the electrons along the way, and other electrons come out the other end. And so the movement of electrons along this wire is known as electricity. Okay, that's the sort of the most basic concept of what electricity is. Well, we usually don't talk about electrons in humans because you don't have a lot of electrons passing through our bodies unless, of course, you actually get hit by lightning. But what we talk about are other charged particles. And the charged particles in the body are known as ions. Now, what the heck is an ion? Well, let's talk about sodium. Sodium, otherwise abbreviated as Na in the chemical list of elements that we know as the periodic table. Sodium, here's a picture of sodium, has 11 protons in the middle of it. So there's 11 positive charges in the nucleus of sodium. And the electrons in a normal atom sort of group together in distances from the nucleus known as electron shells. As you can see that there is one electron in this outer shell of sodium that's sort of farthest away. And so it's really loosely attached to the whole atom itself. Now, there are 11 electrons, right? 11 negative charges. So normally a sodium atom has no charge. But what's the most common compound in our body is probably salt or sodium chloride. Now, when sodium chloride is dissolved in water, such as is in our body, what happens is the sodium and the chloride tend to sort of split apart when they go into solution. And the chloride really, really loves to hang on to an extra electron, and the sodium loses this electron. And as a result, there are, instead of 11 electrons associated with it, there's only 10. Okay, so in a sodium ion, one electron is missing, and as a result, there's one extra proton. There's 11 protons, and there's only 10 electrons, and so the sodium ion is abbreviated Na with a positive charge, a plus sign, meaning that it's charged. So just like electrons moving along a wire, the movement of charged ions such as sodium, and another common ion that we see is potassium in the body, and that it's just like sodium can lose an electron and become a potassium ion. The movement of these charged particles is what amounts to, or what creates electrical currents within the body. And specifically with the heart muscle cell, if you imagine the cell as being surrounded by a membrane, a thin wall around the cell, what can happen is sodium can rush into the cell and make the inside of the cell more positive. And that change in electrical charge, that movement of electrical ions or charged particles, is what generates electrical activity. So now in the next lesson, we're going to talk about how do we record these electrical signals, what's the basic electronic components in a circuit, and we're going to get into much more detail this whole electrical generation of signals in the heart, and later lessons having to do with the cardiovascular electrophysiology. So in the meantime, this is Dr. Nick, and I hope you enjoyed this lesson, and stay tuned for the next one.